$106 a barrel. 35% of the world's crude oil disrupted. Nissan just cut lubricant allocations to 55% of normal. And AutoZone is calling it the largest lubricant supply shortage in modern US history. Here's the thing. It is not the oil we are lacking, but the supply of it. So if the oil you drain today is harder, slower, or far more expensive to replace tomorrow, the real question isn't when's my next oil change, it's should you be changing the oil or testing it first? You might be running a manufacturing line, a marine vessel, a landfill gas engine, or a power station. Different machinery, different pressures, but sooner or later, the same question reaches the maintenance desk. The oil is old. Should we change it? Before hundreds or even thousands of litres are drained, take a sample and ask a better question. What is actually wrong with the oil? Hi, I'm Mark Whiting, Senior Oil Filtration Consultant here at Delta-Xero. Today I'm going to explain why oil testing matters before an oil change, what MPC tells us, what ISO cleanliness codes mean, and why microscopic contamination is often the real problem inside the system. Oil does more than lubricate. It protects, cools, cleans, and carries information from inside the machine. A dark oil sample does not automatically mean the oil is finished. And clean-looking oil does not mean the system is safe. The oil may be carrying water, varnish, sludge, abrasive dirt, silica, or metallic wear debris. So before changing the oil, the first step is to understand what the oil is telling us. One important test is the MPC test, or membrane patch colorimetry. This test helps identify varnish-related contamination. The oil sample is passed through a membrane patch, and the color left behind is measured. The higher the MPC value, the stronger the indication of insoluble varnish material. That matters because varnish does not just stay in the oil. It can stick to valves, pipework, bearings, and internal surfaces. So if you simply drain the oil, you may remove the fluid, but leave the real problem behind. Now let's look at the ISO cleanliness code. You may see a result like 1917-9. That is not a random number. It tells you how many particles are present above 3 sizes: 4 microns, 6 microns, and 14 microns. The higher the number, the dirtier the oil. So ISO tells us about oil cleanliness. MPC tells us about varnish potential. Together, they help us make a better decision before changing the oil. Here is a sample example from a Delta-Xero test on Bindoo T17 wind turbine gearbox. Before filtration, the oil recorded an ISO cleanliness code of 17-15-11. Particle count was severe, with 984 particles per milliliter above 4 microns, 181 above 6 microns, and 15 above 14 microns. The particle quantifier index was 5, confirming measurable wear debris in the system. The insoluble MPC value was 57.1, showing varnish-related contamination. After Delta-Xero filtration, the ISO initially increased to 18-16-12. At first glance, that can look like the oil is getting worse, but this is expected during the active cleaning phase. As deposited contamination is released from inside the gearbox, it moves back into the circulating oil before being captured by the filtration system. So the temporary rise is not the full story. After continued Delta-Xero filtration, the ISO code returned to 17-15-11. The particle quantifier index dropped from 5 to 1, and the separate debris analysis confirmed what had been removed: varnish flakes, abrasive particles, fibrous contamination, and copper alloy material. The insoluble MPC value dropped from 57.1 to 3.3. That is an approximate 94% reduction in varnish potential. High varnish potential before filtration, a temporary ISO rise during active cleaning, a major MPC reduction after filtration, and physical proof that contamination was being removed from the gearbox. That is why oil testing matters before changing the oil. Now let's put particle size into perspective. A human hair is roughly 70 microns wide, a red blood cell is around 8 microns, milled flour is around 25 microns. Fine silk can sit below 5 microns. Now let's come to contamination in oil. Abrasive dirt, silica, varnish, metallic wear debris, sludge, oxidation products, and water-related contamination can exist at microscopic and submicron levels. So the question becomes, how do you tackle contamination that is smaller than what most people are even looking for? That is where Delta-Xero comes in. Delta-Xero filtration is specified down to 0.1 micron. targeting contamination far below the visible range and far below conventional particle size thinking. So instead of changing oil based only on age, color, or routine intervals, Delta-Xero helps you test, condition, and protect the fluid already in service. So before the next oil change, ask yourself, in a time when sourcing replacement oil is becoming harder, is it really worth draining the oil before you know what condition it is in? Thanks for joining me. Follow and subscribe for more videos on filters, oil life, and industrial reliability. And I'll see you in the next session. Cheers!